All right. Hello, everyone. Welcome. It's great to see you all here. Today, we're really excited to introduce a joint project with NASA Disasters and the GLOBE program called NASA Response Mappers. My name is Holly Cole. I coordinate the implementation of Globe Observer under the GLOBE program, and I'm really excited to be here today with you. Just a couple of a little bit of business first. We are recording today's webinar. So if you do not want your face seen or your voice heard in the recording, you can keep your camera off and stay muted. You can please put your questions in the chat and we will address as many questions as we can at the end of today's webinar. So to get started, I would like to welcome the NASA Disasters team. And Kristen, I'm going to hand it over to you to introduce yourself.
Great. Thanks so much, Holly, and thanks everyone for being here. We're really excited to get to share more about this program with all of you. My name is Kristen Oakhorn, and I am a research scientist and also a coordinator for NASA's Disasters Response Coordination System out at NASA Ames Research Center, which is located in California. But I'm from the East Coast originally, so I'm no stranger to hurricane season. And we're very excited to share more about our program and this pilot that we're running with Globe. I'll pass it over to Jack to say hello.
Hi, I'm John Cooney. I've been at NASA as a researcher since 2020. This is my first year as part of the NASA Disasters Response Coordination System. I'm a Center Response Coordinator here at NASA Langley in Hampton, Virginia, and I'll pass it over to Mary.
Thanks, John. My name is Mary Klebb. I'm also a scientist here at NASA Langley in Hampton, Virginia. And I work alongside John as a Center Response Coordinator in the Disasters Program as well. And back to you, Holly.
Thank you. All right. Actually, I think this is yours, Kristen.
Yeah, thanks, Holly. So I'm going to start us off with a little bit of introductory information about what hurricanes are and why we're so interested in studying them and responding to them through NASA. And so hurricanes are essentially these very powerful storms that form over the ocean. So a storm has to be formed over the ocean to be considered a hurricane, although these do often eventually travel and impact the land, which is usually when they become of concern to us. And so any rotating low pressure storm, which is kind of the essence of what a hurricane is considered a tropical cyclone. But for that cyclone to be considered a hurricane, it has to hit a maximum wind speed of at least 74 miles per hour. So that's very fast. Once it passes that threshold, that's when it becomes a hurricane and usually of greater concern for damage and things like that for us to worry about. And so in the United States, hurricanes most commonly impact the Southeast. So they form over the ocean there and kind of will travel over to the land. We have an image here of a satellite image of Hurricane Milton as it was forming from NOAA. You can really see the way that it's rotating and would cause a lot of damage once it hits the land. Next slide, please. So in terms of some of the impacts that hurricanes make, once they hit the land, they can bring a lot of different impacts that can really change the land surface and can be really harmful and dangerous to humans as well. So I'm sure we're all familiar with the strong winds and heavy rainfall that come with hurricanes. Storm surge is another really big concern. So with the usual tides, either from the ocean or other bodies of water, these can become a lot higher and reach a lot further onto the surface during a huge storm. Flooding is also a really major concern, and these really high winds can also bring about tornadoes, so bringing kind of another type of disaster, bringing even more damage to an already really affected area. Next slide, please. Thanks. Hurricanes and the ways that they impact land cover, that's kind of what they all have in common. And so land cover is what we consider really anything covering the surface of the earth, whether it's natural or man-made. So these can be things like forests, wetlands, human-built structures like buildings and roads, agriculture, and many more. So really when we're looking out, whatever we're seeing is the land cover. So if I look out my window right now, I'm seeing some trees and grasses. I'm also seeing concrete and buildings. So those would all be considered the land cover. And so when these hurricanes occur, they can significantly change the land cover around us. So in the image here, that's from NOAA before and after Hurricane Sandy, we can see in the before picture, we've got some water from the ocean, we have some trees, some developments, some roads, some houses. And in the after image, we see that the water has taken over a lot of that initial land space. It's knocked out a lot of those trees. It looks like some of those homes might be underwater. And so these are some of the ways that hurricanes can really affect the land cover of what's surrounding us. Next slide, please.
Did you know that you can see penguin poop from space? That's right, pink piles of poop from those cute flightless birds. There it is, right there.
I'll have a krill burger with a side of squid fries, please.
Astronauts get to see the Earth from the International Space Station every day.
Hello there.
You know what else gets to see Earth from space every day? Our amazing fleet of satellites. Hi, my name is Jessica Mersdorf, and I'm a NASA science writer. I write about Earth science and satellite missions, including Landsat. Landsat has been taking pictures of Earth for almost 50 years. Not like pictures that your phone takes. These are technically images created from encoded bits of data. From space, we can see changes to the Amazon rainforest, growing cities like Las Vegas, the shifting path of the mighty Mississippi River, and even penguin poop. Our planet is changing all the time, from our massive glaciers to your own neighborhood. So, if you had the chance, what would you like to see with Landsat?
Hi, NASA. I would like to ask you a question. What is under the surface of a volcano?
That's a great question. Lots of times there is a chamber of lava under the surface of a volcano. Here's a image Landsat took of Kilauea in Hawaii as it's erupting. With our special technology on Landsat, we can see the heat coming out of the volcano. Here's an image of Mount St. Helens Landsat took in 1979. And here's the same volcano right after it erupted in 1980. Look how the blast from the explosion knocked down the surrounding trees. Amazing, right? Now it's your turn to tell us where you would like to explore. What other changes do you want to see as they happen on planet Earth? Let us know, and you could get your question answered by one of our super smart scientists. So, where do you want to go?
So I wanted to show that to give a little bit more context about how NASA does a lot of this land cover imaging. And so we have kind of this fleet of satellites that are constantly orbiting the Earth and taking these images that look down at the surface. So that can be really impactful for us when these events occur, to have before and after images to see how things have changed, like the images from the previous slide. So with that, I'll hand it over to Jack to talk a little bit more about how we use the satellite imagery, both in NASA generally and also in the disasters program.
Thanks, Kristen. So yeah, NASA utilizes satellite imagery for a wide array of scientific research as well as practical applications. We have numerous satellite-based instruments on over 20 Earth-facing satellites, making a variety of Earth observations. For the NASA's Disasters Response Coordination System, we often leverage this satellite data to provide timely global situational awareness during emergencies to aid in disaster response efforts. For example, satellite imagery can be used to track evolving hazards over time, such as storm movement, flood extent, wildfire progression, and damage severity. It can also be used to identify areas of greatest impact, helping first responders focus on efforts of where conditions are most severe. Next slide, please. During Hurricane Helene, the NASA Disasters Response Coordination System was activated upon request to provide support to federal and state emergency managers. Although initially only minor impacts were expected, Hurricane Helene caused widespread damage in mountainous regions of western North Carolina. In response, the DRCS created a vegetation change detection product from satellite data. You can see here we have this pre-event imagery up above and then post-event imagery below, which is something that Kristen mentioned earlier, where we can take pictures from before and after to identify areas that may have experienced significant wind or flood-related damage. And you can see that with the post-event change there on the right, where we highlight regions that were most impacted. And so this product gave emergency responders a high-level view of where communities were impacted. It was referenced by many partners to better understand both the extensity and the severity of flash flood damage across the region. Next slide, please. Satellite data can be extremely useful for monitoring disasters. It provides us with a broad, rapid view of what's happening over very large regions, but it has its limitations. For example, satellite imagery can be blocked by cloud cover, which is a common issue during storms when we need it most. But even when skies are clear, we're looking at a situation from hundreds of miles above. so the resolution isn't always as detailed as we need it to in order to capture small-scale impacts. On top of that, some of our highest resolution satellites only pass over the same location every few days, so we have to hope for cloud-free conditions in order to get timely, usable imagery. Next slide, please. That's why we're running a pilot project. We're hoping to inspire a legion of citizen scientists in order to gather trustworthy ground-based measurements of land cover. Photos submitted through a trusted source from people on the ground help us to verify and improve what we see from space. They fill in the gaps, confirm the details, and can make satellite data more actionable for first responders. In addition, there's a huge appetite in the emergency response space for ground truth observations. Most people are already taking photos to post on social media. These photos, however, are often difficult to verify in the middle of a disaster and thus are not always actionable. That's why we're inviting the public to be part of this solution. So please help us by joining the NASA Response Mappers. But what is a NASA Response Mapper? This program, as I mentioned, is a pilot project, and it empowers community members to support disaster response through science. Volunteers will use the Globe Observer app, which is available on smartphones, to take repeat photographs of landscapes that could potentially experience storm damage. If you live in one of the targeted states, you'll see a special NASA Response Mapper request in the app, and all you have to do is tap the bell icon to find it. But even if you're outside of this current focus area, your data still matters. Change happens everywhere, and today's calm scene might be tomorrow's before photo that helps responders assess the impact of a storm. This project is open to everyone, and there's no science background that's needed. The more eyes on the ground and the more data that we can collect, the better that we can serve our communities in need. As hurricane season continues to intensify, so does the need for fast, accurate, and local information. And so by participating, you're helping NASA build a smarter, more responsive disaster system, one observation at a time. And I'm going to pass it over to Holly here, who's going to talk a little bit more about the GLOBE program, as well as the Globe Observer app, in which you guys will be taking pictures of land cover imagery.
Thanks, Jack. All right, so for those who are joining from other organizations, to give a little background, the GLOBE program is the Global Learning and Observations to Benefit the Environment program. It's an international citizen science program that operates in 127 countries, including, of course, the United States. Participants in those countries can use a number of different science protocols and upload their observations to a global database. The app of the GLOBE program is called Globe Observer, and it is the tool that will be used for this particular collaboration. So I'm going to show you a quick video overview of what you will be doing with the Globe Observer app to participate in this project. I know that it's very quiet, it's just music, so you're not missing any audio there. All right. So that video showed you a nice overview of what kinds of things you would be doing to take a globe land cover observation through Globe Observer. But I'm going to give you a quick overview about how you get started and then what specifically you need to do to participate in this data request. So the first step, if you do not already have the Globe Observer app, is to get the app. It is free on the Apple App Store or Google Play. The QR code there will take you to our app page where you can then link to whichever platform you need. And this is what the app looks like once you get it downloaded. Should only take a couple of minutes to download, and then we do an update right after you download to get the most current version of the app. The second step is to create an account on the Globe Observer app or on the Globe website. The form looks the same regardless of where you do it, so I'm going to step you through a couple of the fields that you may need a little bit of extra help to identify. First, we're asking you what kind of in what way do you want to participate in Globe? And in your case, you are a citizen scientist. So you're going to select that third radio button, citizen scientist. And then next, we're going to ask you what country you're in. Most people in this project would be in the United States. But anybody in any Globe country, of course, may participate. You enter your email. We do not share your email with anybody. This is just for us in terms of how to verify that you are an actual person. And then we communicate with you on a limited basis that you control, but we don't share that. If you are a former Globe student, you can say yes there. Otherwise, most will say no. And then you can choose your own password. Next, we'll ask you which Globe organization you want to be part of. Since Globe works through schools and other types of education organizations at times, those who are joining through that organization can select that. But for you, you're going to select use the default. This will put you in the citizen science organization for your country. The next option is to join a Globe team. And to participate in NASA Response Mappers, we want you on the team for that project. So you're going to select join a Globe team. And then you are going to enter the referral code when their little screen will pop up and a little pop-up box will open up and it will ask for that code. Don't worry if you don't remember this. The URL for the team is there. It will also be the little data request that when you tap on the app to learn about NASA Response Mappers, it will also be there. So you have information about it other places, but you'll just enter that code. You can also search for a team and type in NASA Response Mappers and join that way. So the account setup process will ask a couple of other self-explanatory things, like you can set up a screen name, but that's basically it. And then once you have your account, you've downloaded the app, you log into the app with the new password and your new account, we're going to ask you to take a little bit of in-app training to make sure you're comfortable collecting data using Globe Observer. So you'll tap on land cover, which is the third button down on that Globe Observer home screen. And then you'll have 3 training options. The first is photograph the land, and that's the one you need to take. The other 2 are optional. They'll allow you to do a little bit more with land cover, but they are not required. And for this particular project, photograph the land is the only one you need. So once you've taken the training, you're ready to go. Your next step is to choose an observation site. We want you to go to a place that you can get back to easily because we want repeat observations from that site. We want you to take observations preferably once a week, but at least once a month throughout the time period, August through October. That is the ideal. So if you choose a really interesting site that's difficult to get to, it might not be as useful as your backyard, for example. The second thing to consider is, do you have permission to collect data at that site? Is this a place that has restricted access or is private land and you don't have permission to be there? So is it okay for you to be at that site? Third, is this a location that's likely to experience change during a storm, such as a flood-prone site or a place where tree damage or erosion is likely? And that might be a really good place to be taking those detailed observations, because you're going to be showing the disasters team where you are documenting damage. Now, you can't know that for sure ahead of time, but you do your best in choosing that site. And then finally, and perhaps most importantly, no, perhaps, definitely most importantly, is, are you safe? Can you safely observe from that site? And if the answer is no, please don't choose that site. Every measurement is useful, so no matter where you choose, we're grateful for the data. It's going to be helpful. You can always observe a location after a storm, so if a place that you didn't predict receives some storm damage and it's safe to take observations from that site, great, you can go to that site and take repeat observations from that point forward. So even if you didn't take a before image at that site, it's still a good place to take observations. So the fifth step is going out and collecting data. So from the home screen, you're going to tap that land cover tool button, and then it will take you into launching the observation. So the first thing we're going to ask for is the date and time. That should autofill in your phone. You can adjust it if you need to, but that should be accurate. The second screen is going to get the location for your observation. And you see underneath the map there, we'll put a pin in the map, and then underneath we'll estimate the accuracy of the location. If you see a large number in that estimated accuracy, like 100 meters, anything over 30 meters, hit the reset button a time or two. That gives the app a little bit more time to narrow down your location to a specific spot. You can also use 2 fingers to move that pin on the map to a more accurate location. If you're offline or have a poor signal, you might need to do that. As a side note on the location, this is not something, it's something we need for the data because we're trying to compare to a location on a satellite image. However, it's not something that we share beyond that. And also your data in the Globe Observer database is not connected to your email in a public way. So that location will be kept private and that is not connected to you. So we value your privacy and we take that very seriously. So after you do date, time, location, we ask about surface conditions, and that means that we're asking you to tell us a little bit about what it's like on the ground, things that change. So is there water on the ground or is it dry ground? Is there snow or ice on the ground? Probably not in the states that we're taking this data. And those are all just yes or no questions, and they're pretty straightforward. And there are things that vary over time that might change the way you interpret a satellite image. So it's really useful to have that. And then the next step is to take the pictures. So the app will prompt you to take photos facing straight up so we can see what cloud cover looks like, and then straight down so you see the surface of the ground. You'll probably get your shoes in that picture. And then after you get your up-down pictures, you're going to be taking directional pictures. You'll need to rotate your phone landscape to take those pictures. And then here's what that camera screen will look like. We have an embedded overlay that uses your compass in your phone to detect the direction. We want the pictures facing north, south, east, and west. This makes it much easier to know how your pictures compare to what is shown in the satellite data. So you're going to move your phone side to side until that little E in the circle lines up with that center stripe. And then you'll tilt your phone up down to focus on the area about 50 meters ahead of you. If you can picture standing in the middle of a football field or a soccer pitch and taking a picture out to the goal line, that's what you're targeting. So you'll do that in each of the cardinal directions. And when you have it aligned properly, you tap the screen, that takes the photo, and then the little circle on the bottom left will turn green when you have the photo, like the up and down circles are right now. So after you take your pictures, you'll get the opportunity to enter any field notes and share anything about the site that you think is going to be useful. You might provide some context. You might say something like, this is a place that has been damaged in past storms, or you might say something like, it's flooded right now, or it's dry, or I see no change, or I'm documenting Hurricane Helene, whatever contextual information you think would be valuable to somebody interpreting your data would be useful to add here to this field. Then the next opportunity or the next step there is you have the option to add additional photos facing other directions. So say there's a landslide and it didn't end up in your north, south, east, or west photo. It's a little bit to the northeast. You can focus on that landslide and take a picture of it. And then in the caption field that you see on the screenshot on the right there, you can enter a little bit more description about what is in that screen or why you took that picture. You can take up to 4 of those special feature photos. So when you're done taking pictures, you will get a screen that said, okay, you're done. Would you like to analyze the land cover, or would you like to skip it and save the photos? And at this point, you can be done. Your participation in NASA Response Mappers is done at this stage. However, if you would like to analyze the land cover, tell us what's in the photos by classifying the land cover. That's really helpful, because what that does is it essentially tags the photos with the land cover type, and it makes them more findable in the database for scientists doing other kinds of research in the future. So it's really helpful if you can tag the photos, but not essential. If you do want to classify the photos, you will need to take that second phase of the training, and that will show you exactly how to classify the photos. The app will also step you through the process. So once you've done as much as you want to, you'll get a review screen. You'll see your photos. You'll see a little pencil button if you need to edit anything, like add additional field notes. And then once you're satisfied with your observation, you click Finish. That will take you to the last screen there is a data screen. And you can save your data to submit later. So if you're offline or it's after a storm and you don't have very good connection because everything's offline, then you can just save it and submit later when you are back online again. That little icon on the lower left with the little red 1 in it, the little bar graph, that tells you have saved data ready to submit. But when you're back online, you have a strong connection, then you can click that Send Observation to Globe and send it to the database. So what happens to your data? It goes into the Globe database, which is free and open to anybody to use. There's a couple of ways people can access it. I'm showing you the visualization system right now. You can also see your data on that team page. So this is the page for the NASA Response Mappers team that I told you about earlier. Your data will show up on that map there. And then under member observations, the screen name that you choose or an anonymous ID will show up here. And you're the only one who knows that ID. So you're the only one who can identify yourself in there. But you can see your data there on that member observation and in that map. The third way you can see your data is through the Globe Observer app. If you click on My Observations here, it will open up whatever observations you have. So once you hit Submit, give us about 15 minutes. Within 15 minutes or so, it should show up in the database and you'll see your observations. Some of the photos may be delayed. We do screen all the photos before they go into the database. Most of the time, the photos go through pretty much immediately, but occasionally they will be flagged for additional human review, and in that case, it might take a little bit longer. All right, so if you've taken the data, you run into an issue, the app isn't working as you thought it should, or you're not sure about how to do something, you can always reach me or a member of the Globe Observer team. You can click on the small question mark icon in the app on the lower bar, or you can go to the Globe Observer website, observer.globe.gov, under About, and select Contact Us right there. It pops up a web form that then will come to my inbox or others on the Globe team. And we're happy to hear from you and answer your questions as quickly as we can. All right, with that, I'm going to pass this over to Mary.
Thanks, Holly. So before you head out and take any observations, I want to reiterate something that Holly said earlier, and that is to please stay safe. We will never ask you to go outside during or immediately after dangerous conditions, and only take an observation from a safe location. And remember that taking routine observations once a week or once a month is still helpful, and you can still help us to collect data without putting yourself at risk. Next slide, please. So you've learned a little bit about hurricanes, how NASA uses land cover measurements for disaster response, and some of the limitations of satellite data, and how to get involved. But why get involved? What will your observations do? How will they make a difference? Your observations are unique and new. And while sometimes photos are posted to social media showing damage from a storm, those photos are not geotagged, which is what first responders need. Your observations can help tell us if satellite maps are accurate at your location. This satellite map on the right showing a blue river, the red spots is where flooding is indicated. And your observation can help verify that flooding is indeed occurring in that location, or maybe you're near the edge and it's not flooding where you are. You can provide information if there's a delay in acquiring satellite data due to clouds or timing. Your observations can reflect damage to roads and bridges, the extent of floodwaters, and even damage to croplands. And your observations can provide new resources for first responders to help those affected by disaster. They can help first responders identify and prioritize damage. They support disaster declarations and aid in equipment staging. And they can extend situational awareness and provide eyes on the ground in areas that responders can't immediately access. And they can even guide pre-storm preparations. Before a storm, photos might highlight vulnerable areas, showing overgrown brush or unstable dunes that need mitigation before a storm arrives. Next slide, please. So here you can learn more about NASA's disasters program at disasters.nasa.gov. And you can join the NASA Response Mappers team at this URL, and you can get involved and help NASA help you. So now, if we have any questions, we can go to questions now. So here's a question. I'm going to direct these questions to Kristen. It says, I'm already active in collecting cloud data. Can I join the NASA disaster project under that account, or do I need to set up a separate account? Okay, I apologize. This answer should probably go to Holly.
Yes, absolutely. You can join with your current account. That goes for all people who are already participating in Globe. You can use your existing account. In fact, we encourage you to do that. You will want to join the NASA Response Mappers team so that your data is collated with that team. And to do that, Haley kindly put the link in the chat there, but that URL will also appear on the project page that you will get to from the app when you click on the little alarm bell to launch the project. So, but just join the team with your current existing account, and that would be great.
Okay, the next question is, would the view from the top of an overpass that covers a wide area in a metropolitan area be useful? And this one is for Kristen.
Yeah, so I think that one question is it useful? Two other questions that immediately brings up for me are, is this a safe place to take observations? And then number two, is this somewhere that you can routinely get to every week to make an observation? And so I think for questions 2 and 3 that I've just posed, it might not make the most sense in terms of if there's a hurricane or some other storm, is it safe for you to be standing up on top of an overpass, rather than just outside your own home or somewhere else, kind of in your local area? And then if you're having to travel somewhere to get to an overpass to take, kind of a higher angle observation, is that an additional barrier to entry that, you're not going to remember or think to go to this, kind of external location rather than just stepping outside? So I think it could be useful maybe, but I think that just making sure that the location is safe and accessible is probably the most important thing. I think that wherever you are, just if it's an accessible location that you're going to think to go every time is probably the more important thing than going somewhere specifically to take an observation. I think that any observation is useful, whether it's the sidewalk on the overpass or if it's just outside your own home or, somewhere where you live or work. I think that any observation is useful, but just limiting the barriers to entry of making that observation routinely, I think is the most important thing. We'd rather have you make the same observation once a week or once a month rather than getting just one observation from that location, if that makes sense.
Okay. The next question is, will response mappers GIS layers be available on Esri AGOL?
Yeah.
So,
Oh,
go ahead, Kristen.
The answer is most likely. So our website that we'll be posting a lot of the data from is hosted by ArcGIS Online. So that is kind of the planned platform for using it. I don't know exactly yet how we'll share the layers because we don't have any data collected yet. So Mary, feel free to chime in if you have additional information, but that is the platform that we'll be using. So in theory, but we can share more information about how to actually access the data once we have a few observations to work with and have those available to publicly share.
Okay, excellent. So that's all the questions we have right now. While we give a few minutes for a few additional questions, let's see. John, would you like to make any closing comments?
Yeah, thanks, Mary. I just wanted to really thank everyone for their time and interest today in the program. NASA loves satellite data, and satellite data is a very powerful resource, but it's even more valuable when you pair it with observations from people on the ground, and that's where all of you come in. And through this NASA Response Mappers pilot project, you really have the opportunity to directly support disaster response, improve scientific understanding, and help your community prepare for and recover from storms. So whether you're an educator, a weather enthusiast, or someone who cares about their community, your observations matter. One photo, one observation can really make a difference. So please consider joining us, spreading the word, and becoming a part of this effort to build a more informed and resilient future through the NASA Response Mappers pilot project. Thank you, Mary.
There's another question that came in the Q&A that I think might be for Kristen, and that is there a preference between urban and rural areas?
Yeah, that's a great question. And I would say no, we're very excited to have images from any location. So wherever you are, we'd love to see it. So really, wherever you are, send us a photo, please.
Any other questions? One thing I would love to emphasize is that we are making this data request to people in those 11 states that you saw on the map early on in the presentation. But anyone who collects data and shares data is contributing useful things. And I know I'm excited to go participate in this. I live just barely outside of one of those states, very near the border, but I still plan on participating because I'm really excited to be able to contribute data to this project that could be useful for disaster mapping at some point in the future. So even if you don't live in the area, I encourage you to join with us. So Devin notes in the chat that the Response Mappers team should connect with Photo Mappers team at NAPSG. Sorry, that's an acronym I don't know yet. It's a very similar project with similar goals related to disaster event response.
Yeah, we actually have someone on our team who was a one-time photo mapper, but they've had to step back recently, so they're very familiar with that program. And that would be something that we hope to maybe work together or something in the future. Yep.
Thank you. Any other questions? Well, if you have a question later, the project, let me grab the project page for this, has contact information for the NASA disasters. And as I said before, the contact us on the Globe Observer website or the question mark in the app will come to us. So feel free to reach out anytime. We're happy to have a conversation with you. Give me half a moment and I'll give you the project page for the NASA Response Mappers data request. There you go. It's in the chat now. So we have information. We'll be adding additional information to that URL, to that site, including ways to get in touch with us. So thank you for coming today. If there are no other questions, I will wrap it up. Thank you so much for joining us.